and thank you for joining us from around the world. I'm the chair of today's lecture. My name is Ryosuke Hosaka from Shibaura Institute of Technology, Japan. Before starting today's lecture, I'd like to make a brief announcement about the IEICE Distinguished Lecture Series. The Institute of Electronics, Information and Communication Engineers organizes the Distinguished Lecture Series as a part of its initiative to expand its international memberships and foster global academic exchange. This program provides world-renowned experts, distinguished lecturers, to share their insights, cutting-edge research, and visionary perspectives on the future of electronics, information, and communication technologies. The IEICE offers a series of webinars in English delivered both live and on demand, allowing participants from around the world to access lectures by leading researchers and professionals. Hosted by the IEICE International Affairs Committee, this series provides a valuable opportunity to learn about global research trends, technological innovations, and emerging fields. We warmly welcome students, researchers, and professionals worldwide to join us in exploring the future of technology through the IEICE Distinguished Lecture Series. So, now, let us turn to today's lecture. It's my great honor to introduce today's distinguished lecturer, Professor Luigi Fortuna from the University of Catania, Italy. Professor Fortuna is a renowned expert in systems theory, nonlinear dynamics, and control engineering. He received his degree in electrical engineering in 1977 and has been a full professor since 1994. Professor Fortuna has also served as a dean of the engineering faculty and director of the PhD program at the University of Catania. Over the course of his distinguished career, he has authored more than 700 scientific papers and 13 influential books, covering the topics such as the robust control, cellular neural networks, and chaos and soft computing. His academic leadership has been widely recognized, so he is a fellow of the IEEE and has served on the editorial board and international science committees. Notably, Professor Fortuna has also been honored as a fellow of the IEICE for his outstanding contributions to the design of circuits and systems by exploiting their hidden nonlinearities. So please join me in giving a warm welcome to Professor Luigi Fortuna.
Results referred to linear time invariant systems that is for me the basic of all my studies in my career. Therefore, I'll want to discuss the main results I achieved in the last 10 years in order to stimulate new generation to give attention mainly until now to the linear time invariant systems. And I prove that more and more new results could be achieved because it is not enough truly discovered more results in this very particular class of systems. But the beauty of this system is that we can prove results in a closed loop form, and we have to start with these results to give practical and continuously fascinating application. Therefore, my lecture is addressed to the new generation mainly and it follow the roots that I had in this particular field of my research. So the lecture is organized in this as follow. I give briefly some introduction on the roots that I just starting to arrive to the new results that are presented briefly in 18 papers published in specific journal regarding automatic control and system theory. Therefore, I remark that this type of results are related to linear system and not to my specific field of nonlinear science, nonlinear engineering, and nonlinear electronic circuits. But without these results, I cannot add the possibility to establish further results in more complex systems. I'll present some conclusive remarks, and I referred to the last slides, to the last page of this presentation to give essentially a very recent results that has been in perspective established for future. And the last we just arrived to the last page, because in the last page there is very new project that has been established in the last month. Now, which is the context of we are working? This is the context is referred to linear time invariant system, classically represented by a transfer function GS or state space representation given by the matrices A, B, C, and D. Therefore, this is the case of collinear continuous time systems that are the main subject of this discussion. Moreover, I want to remark that other important concept is referred to the frequency transformation. In linear time invariant system, so we are considering the Laplace transform S. But what happens in the system if instead of S, you can introduce a further transfer function Fs or transfer function or transfer function matrix. This is called the frequency transformation. It is well known in people working in electrical circuit design. Moreover, we push attention to do the frequency transformation when Fs is a lossless function. This means that is a transformation that describes the impedance or the admittance of a passive circuit but conservative circuit without lossless. That is essentially given by inductors and capacitors. So it is a very important transformation that I give you where we referred more of the results I obtained. Of course, this is the form of discrete time, linear time invariant system, and obviously there are some concepts that are common both in continuous and in discrete time, but more of the results to be generalized for linear discrete time system. It is not immediate from the continuous linear time system. Therefore, it is another remark. Now, which is the beginning of this story? The beginning of this story are my university studies. Therefore, what I want to do now is to push, to remark the attention of the people to the study of the master degree during the university people, the university time. In particular, this is a reference K book that that addressed all my activity, research activity, and educational activity. This book regards automatic control system. It's an Italian book and has been published by Antonio Ruberti and Antonio Lepsky that are the fathers of automatic control and system theory in Italy. And this is the first book that I take in consideration during my career and that I was fascinated by this reference book. Another book is another Italian book. It regards electrical networks. This is the design of filters, the design of electrical networks by Giuseppe Martinelli. And there is a related strictly connection between automatic control, compensator design, and filter design. That is the subject of this book. Now, system theory. This was the first book of system theory, 1973. System theory has been in Italy established by Sergio Rinaldi of Polytechnic of Milan, and it is for me another reference book that it is now, until now, on my table, and I continue to look and to study. Another book is the System Theory book from Antonio Ruberti and Alberto Isidori. Alberto Isidori is well known in the world for the theory of nonlinear control based on differential geometry. Now, this was the first book I introduced, but there is a very important article that is for me a reference article that has been published in 1981, Principal Component Analysis in Linear System, Controllability, Observability, and Model Order Reduction by Bruce Moore. And in this book has been introduced for the first time what has been done is being called invariant of the system, and in particular the singular values of the system. The singular values of the system are invariant quantities of a system. This means that they do not depend on the representation of the systems, are invariants. This is the meaning of invariance, quantity of the system that characterize the systems and do not depend on system state space representation. The first paper that introduced invariance has been done by Bruce Moore, then followed other papers that will try to define other invariants, like the characteristic values that has been introduced by John Keir and Silverman in the 80 years that represents some quantities that give us the peculiarities of a linear time invariant system as regards the problem of linear quadratic regulator, while therefore sigma 1, sigma 2, sigma n, the singular values are referred to open loop representation of the system, the characteristic values of the system are invariant quantities that they give us the information about the possibility of have success in LQR problem control design. Moreover, we have in the story the other other invariants. In particular, if we are restrict our attention to positive real system, this means to passive systems, there are some quantities that characterize the degree of passivity of the system and are given by π1, π2, πn, are invariant of the system in the case we are considering positive real system. And of course, there are other invariants of the system that characterize bounded real system. This means what bounded real? We mean system where the H infinite norm is less than 1. Of course, this is the root and the importance of the last one of the bounded real characteristic values has been a lot involved in H infinite control problem. Of course, from a mathematical point of view, the first class of invariants are related to two Lyapunov equations that are the gradients of both the controllability gradients and the observability gradients. And there are two equations. The second are the characteristic values are characterized by these two equations that are the control algebraic Riccati equation and the filtering algebraic Riccati equation, while the other two are referred to other two Riccati equations that are particularly defined for positive real systems and for bounded real systems. Therefore, these invariant characteristic values, these invariant quantities are related anyway to a couple of equations that define the main features of the system. Another book that it is very important and it is established now for that will be involved in some result of my research is this classical Popov book. This is the hyperstability of control system. What is the importance of hyperstability theory? The hyperstability theory allow us to discuss about the stability, the asymptotic stability of this system of a control feedback system, and we can get information on the stability of it working only on GS and KS. Therefore, to have a simplified sufficient condition to be the system stable, we can look directly to both GS and KS. Therefore, the system given in the figure is asymptotically stable if both GS and KS are positively real. This means that is a very important condition to study also the robust stability of the system. Moreover, and therefore, we have a dual results regarding of course, the stability of the system by working indeed on the specific characteristic of GS and KS that establish as the structure of GS and KS if they are positive real or strictly positive real, assure the asymptotic stability of the system. Of course, there is related to this scheme another theorem that is not mentioned here, that is the small gain theorem. This is related to the bounded real properties of both these two systems. This means that if both of these two systems are strictly bounded real, the closed loop system is asymptotically stable. Therefore, the characteristic values referred to the bounded real system and the positive real systems are also important in the study of stability of closed loop system. Now, we go in this. I just mentioned some concept. And another very important concept I use in the next features of my presentation is the feed-forward control scheme, because generally people is interested in the feedback control, but is not truly interested in forward action that could be performed in each system. This is a scheme that allows us to define the forward action in a control scheme when we use this action by working on some parameters of this block and we couple directly the input and the output. This is the forward action. Forward action is fundamental even if in literature is not studied in more detail. Now, based on that was my summary of information referred to general guidelines in the future results. I give you a view of my results. What is the HIME? The HIME is this. We use very simple theory based on the previous outlines to get important results that had not before discovered in the literature. I refer, for example, to the one paper that is related to the possibility of making a system, a multi-input, multi-output system passive, this positive real, working on one only parameters. This is very important because allow us to make a system passive. If I can make a system passive, of course I can use the hyperstability theorems, theorems and perspective given by Popov to get important result in robust control. Therefore, this is a design paper where we can use one parameters to make this system here passive and have a lot of improvements in the asymptotic stability of the closed loop system that is indicated in the figures. Another second paper, this is the invariance of characteristic values and L infinite norm or H infinite norm under lossless positive transformation. As you remember, I indicate a transformation when we'll introduce instead of S a transfer function of or a transfer function system inside the original system. This is truly very important in design of filter, analog filter, and it is a timely problem, the design of analog filters, due to the fact that technology allows us to design in silicon high performance analog filters. What does mean this paper? This means indicate that even if we'll introduce high order transformation of this system, the characteristic values and then the possibility of working on the control loop scheme of the system is invariant. This means that the characteristic values of the system do not depend on the lossless transformation of the system. Now, the working forward action to make a system negative imaginary. So as you can see now, this is a this is a Nyquist diagram of a system. If we have a Nyquist diagram like that, we have more possibility to have a robust control system, because the critical point is isolated, and negative imaginary part is anyway negative, and if you have this condition in one system, is very good for the stability. Moreover, we can have a transfer function GS that has not this characteristic. We can achieve this characteristic by working again with the forward action. This is a very nice results that give us more further possibility to study the robustness of the system. Of course, the positive real system, that I mean the positive real system is the passive system, and I mean the system made by passive components. And if we adopt in this type of system lossless transformation, of course, the characteristic values referred to the positive real systems, so the third class of invariant system that before I mentioned, are maintained invariant. This allows us to have the possibility of, in spite of the increasing dimension of the system that is due to the introduction of frequency transformation, we can use reduced order invariance with the same characteristic of the original one. Anyway, it is we have the continuous time linear invariant system under lossless positive real transformation of a loop representation and truncated reduced order models. This is again give us the possibility of using the lossless positive real-time transformation to have this led us to increase the order of the system, but we can achieve reduced order model order that represents suitably the original one, but we are guaranteed that the overloop singular values of the system are maintained. Now, this is we are working directly on lossless system. So the lossless system, I remember, are that are built by inductor and capacitor, and ideal inductor and capacitor. This is the story. But today, ideal inductance and capacitors could be realized if we are working with components working in a cold temperature. This is due to quantum computing devices, and this ideal condition has have been just now really obtained. Therefore, the importance to get this type of circuit and to analyze the lossless system is very important. What's happened if if we will have uh, uh, this class of system, the characteristic values of the system, if we will introduce the impedance or the admittance of this system, has been proved more times ago that all the characteristic values are equal 1. So what we say, the characteristic values of a lossless system are identically equal 1. But we have here V and we have here I. Let us consider the same scheme, the same nature of the inside the components. But if we want to derive from this one the other transfer function, other behavior, when you have for example, one input and one output, this is a voltage, not a current like that. Of course, the characteristic values are not equal 1. Moreover, it has been proved that these characteristic values mu1, mu2, mu are related in this way. If mu1 is a characteristic, 1 over mu1 is mu2. If mu3 is a characteristic, values 1 over mu3 is a characteristic values. Of course, if it is dispari, come si dice? Dispari. If the system is odd, we have one characteristic that is 1 and the other that is 1, the inverse of the other. Nyquist plot under frequency transformation. So the frequency transformation maintains, in particular, we are considering the lossless transformation as that before discussed, and the frequency transformation, the lossless frequency transformation maintain the shape of Nyquist plot of the original system. So if we'll include, instead of S, ith order frequency transformation, the Nyquist plot does not change, and therefore the higher order stability properties are the same of the low order one. It is fundamentally important for the robust study of high order analog filters. Of course, again, the forward action. The forward action is fundamental in, as I mentioned before, and in our experience, also in making time delay system to deal with time delay system. And with the ideal for us is to have a system, to modify this system, and to have, by using this new system, some peculiarity of this new system that make it suitable for feedback use. But what has discussed before, positive real or imaginary, negative imaginary system are ideal to be guaranteed to be asymptotically stable in closed loop frame. But before to do it, we can use a forward action. This is made, let us suppose GS is a time-delayed system. By using a forward action like that, we can make it positive real or negative imaginary. It's very suitable for control loop robustness performances. Now, as we can, the feature of my presentation, one of the first slides regards the characteristic values, the singular values, and so on. This is a very fundamental in the study. Therefore, what's happened if I have a system and will use in a cascade another system that is an inner system. This means a system also like all pass system. So it is a system with the transfer function is constant modules and working only in the delay and in the phase response. So we have a one system, this is our system, and we couple it with the all pass system, or it's an inner system. What's happened is this, to study in which manner the singular values of this system are modified by this action. What's happening is this. There is the important results is this. This is for MIMO or for single input, single output system. In particular, our attention is devoted to the relation between the anchor singular values that are the singular values of the system or the characteristic value of the system, and if we couple with the inner system, we have that each transformed the singular values of the transformed system does result each one greater respect that of the original one. It is very important because allow us to establish some properties about the singular values of a general system with that of a minimum phase system and non-minimum phase system that are critical in the control. These properties, that is a very technical aspect, with a very technical aspect, and is also extended for discrete time system. Okay, anyway, the subject of the importance system with delay, the delay is critical in the study of robustness of the system, and therefore when we have a delay, we have critical properties in studying the closed loop behavior of the system. And in this discussion, we'll prove that with only a feedback loop on the state, we can make the system with commensurate multiple time delay independent of the same time delay. So a very simple action, a very simple linear regulator could make a complicated system independent of the time delay that is present in this scheme. So we are working only on this part. We make the feedback of this of the linear control of this not delayed system to make all the system independent of the time delay tau. Of course, the previous results regarding the Nyquist plot as under frequency transformation has been extended also for multi-input, multi-output system where the Nyquist plot is a complex Riemann surface and is not immediate to draw with hand and pen plots, but required a computer computation. Moreover, the result it is maintained until now. This means that the frequency transformation is an important property that maintains some peculiar properties of the system invariant. This is the same case for the frequency transformation in the discrete case. And here you have in this paper a new asymptotic stability criteria for linear discrete time system. So it is a very immediate results. We are working on stability, on closed loop stability. You use the Root-Hurwitz criteria that is very old, very simple. In this paper, we extend this one of these criteria in a very easy manner to discrete time system, and we are able to get very suitable results, immediate results, and the possibility of implementing it in a piece of paper in order to establish that the closed loop poles of the system are inside the unit cycle region. Of course, our attention has been paid to linear quadratic regulator problems, and it is the case of quadratic regulator problems, of course, for lossless system, for continuous time and discrete time system. It is a very fantastic results because in this paper we prove that the gains of the compensator, the gains of the observer cannot be directly obtained looking at the system. Therefore, it is not necessary for lossless positive real system to compute linear quadratic regulator by using Riccati equation and something else, because they are directly related to the B and C matrices. So the optimal gains are the B matrix, the optimal observant gains are the C matrix without making any type of computation. This is fantastic. You can look at the system, you have only to prove that the system is lossless, and you have immediately the gains both of the regulator and the observer, and therefore the observer and the compensator is directly computed. And it is well known the generalized Ladle formula for single input, single output system. It means that if you have a transfer function, we can directly define the closed loop optimal poles solving this polynomial equation. So another very interesting results given by Ladle allow us to get the closed loop poles of the system without referring to the Riccati equation and some numerical computational problems, because it is related, the closed loop poles are the real, are the negative real part poles of this system. It is immediately, and this problem is related to an algebraic problem. In this paper, we'll generalize the results given here for multi-input, multi-output system and for not strictly proper system. This means that when we'll in the original letter formula is very simple, then very simplified in the hypothesis. We extended the case of multi-input, multi-output systems and will relate it to the not strictly proper system. The same has been proved for discrete time case. So, but even if the results are the same, the proof of these results required a lot of modification. Anyway, the forward action again we have used to stabilize and multiple time delay multi-input, multi-output system. So when we established that the time delays, we can make in the system a system with more time delays inside it. In the previous case, when we discussed with time delay, we referred to time delays that are essentially that are time delays or the multiple of one delay. So we have T1, T2 is 2T1, T3 is 3T1, and so on. But in general, we have here not multiple of time delays, we have different scales time delays. Of course, by working with a forward action, so we can push with this forward compensator to make this closed loop system asymptotically stable, independent on the time delays of the transfer function GS tilde. This is anyway the body of the 18 papers I introduced before and I studied until to 22 years, but the study is continuing now. Now I give you a brief summary of what we have done. And of course, we have here as a discussion. So we have a link table. So we have lossless systems, singular values, characteristic values, forward action, delay, model order reduction, LQR, and positive real system and other items. And we have here the paper from 1 to 18 and the relationship that are by using these key topics and this paper that this is some relationship between the list of paper and the type of papers I presented. What is the importance? So it is the papers I discussed before indeed are related by my first research topic that regards robust control and that I studied with Peter Dorado and Professor Peter Dorado from University of University of New Mexico and Albuquerque in 1990. And we have this pretty classical book on robust control. So it's the idea generated by working in this topic. And other key point book in my career has been model order reduction techniques with application in electrical engineering. Therefore, what we say is to get model order reduction, reduce the order model to reduce the complexity of the compensator in spite the possibility of uncertainty there, and therefore the topics and the papers that I presented are a lot of them related to this subject. Indeed, as you can see, but we have just now results. It is a very old conjecture. So 5 years ago, So we have a transfer function, we have a GS, and if instead of S, we will introduce instead not a transfer function, but we introduce a system. This is a multi-input, multi-output system. Anyway, this is a lossless system, multi-input, multi-output system, and it is true that the transformed system maintains the same singular values. Now, this is the ideas that is a conjecture that I established 5 years ago. But today, now, this conjecture has been a theorem and will be published in recent journals. Now, with this means that we are considering to transform system with other system. This is the topic of system of systems, and system of system in linear time invariant condition could allow us to get suitable results that could be proved exactly. And ideas in progress. This is a very simple. So what I would like to remark is this, that more of the results I presented before derived first of all before from conjecture. After conjecture, we go to prove, to make the conjecture a theorem. This is the root of the previous paper. It is an idea in progress. I have here, for example, a Lyapunov equation. If A is a stability matrix in companion form and Q is semi-definite positive solution, we have a conjecture that P is not only positive definite, but each term of P is greater than 0. This is a very simple conjecture, but not until now proven. So if you are interested, you could try to make this conjecture now theorem. This is a very hard idea. I give this problem, I propose this problem to more important, more with researcher in system theories, with high skills in algebraic methods, and the answer has not yet given. Moreover, you can make a lot of examples with MATLAB, each other, every other, this does work, the conjecture does work. So I invited who is interested to investigate on this conjecture. Now we are going to idea in progress, and it is the idea in progress is established as some problems, and the problems require then to go on to proof. For example, the necessary and sufficient condition for the system to be strongly stabilizable is that between any pair of zero with positive real parts, there is an even number of poles. What does mean? This means that if this condition is maintained, we can make a compensator that is stable. So we can use lead-lab classical networks to make a compensator. So this property is very important to be guaranteed that we can use stable compensator to have a closed loop stable system. Now the idea is this. What is this? This is a system that is not strongly stabilizable. Why this is strongly stabilizable? We have two poles in the right half plane between two zeros. This is strongly stabilizable. This is not strongly stabilizable. So now, under which condition does a work action make a system strongly stabilizable? It is not, we have not until now a definite general answer. Therefore, it is another idea that could be developed. Of course, another problem is this. We have more plants. We have more plants. Does exist a unique compensator that allow us to stabilize all the plants? Okay, this is a good problem. The result is not only when we have two plants. So you have two plants, we have necessary and sufficient condition when it could be done. But in general, for more plants, does not exist a results. The results for this is a very good problem. Now, I am working today to generalizing the letter formulas for both for bounded real system and for positive real system. Indeed, we can have a very simple methods to guarantee that the system is bounded real and positive real, analyzing the roots of these two polynomials. And I anticipate that if both the root of these two polynomials are not in the imaginary axis, respectively, the first system is bounded real and the second one is positive real. It is proof is just working now and will be published in the next feature. Now, in this lecture, some results regarding undiscovered point of linear time variant system has been summarized. Most of them have been just used in electronic companies, both to design innovative circuits and to update existing design software tools. The hope of the presented research is to give us the message that there are a lot of unsolved problems in linear time variant system until now at the edge of machine learning and artificial intelligence era. The research aim is to study and to apply, to discover the simple solution, to develop both method and theories, to be active in the mind forever, to be critic. First of all, researcher must guarantee the knowledge of the next generation of free people. Ensia non sunt multiplicanda praeder necessitatem, which translate as entities must not be multiplied beyond necessity. This is the Occam dictum in the 4th century. I hope that more people will follow this route. I just gave this again and again new results that arise after presentation, and I am working on the scattering relationship between the bounded real system and positive real system. This is a mistake. Positive real system and bounded real system. The inverse of positive real system is the same characteristic values of the original one. The characteristic values could be defined for imagined negative system. And I just now, before the last transparency, I want to thank the friends of IEICE society that are only splendid colleagues, and the society is in my heart. So grazie for this presentation. Moreover, I have just the last one transference that is it is very significant today because it regards some details about artificial intelligence feature. But look at. So Maieutic, a long dialogue around the modern automatic control. What does mean? I have to establish the previous results of my career, making a lot of discussion with students, with professors, with people having more experience of me. And this is a continuous route that has been going on that allowed us today to get the previous results I presented. So the discussion, the continuous dialogue that has been in Greek people very well established is a particular feature in our developments. Therefore, what I just working is to rediscover all my discussion, my dialogue with all the people in the last 40 years to point out the new points in the automatic control route. Moreover, this is indeed the results we are just given now is due to this aspect. Moreover, I have been inspired now by the use of ChatGPT, and therefore I want to make a comparison between my dialogue, real dialogue with a lot of people working in automatic control. I give, for example, Peter Dorado, Lofty Zadi, Leon Chua, Thomas Roska, and something else that reached my knowledge and explain together, work together in more control problems and give me the feature of my knowledge in automatic control. And I want to make an experiment to investigate on ChatGPT and to give to the ChatGPT the same question that I gave to the people working for me in the last 40 years. The results has been preliminary, but what is my previous feeling is this. I posed the questions, and anyway, the system, what has been formalized in 20 questions with people, real people in the world, and give me the information, and we have get some results to achieve a limited part of the result or limited part of suitable answer. I need to make 45 questions to ChatGPT. Moreover, more of the questions are not truly answered in a satisfied manner. Anyway, the problem is this. I use the ChatGPT is in a myetic approach. Anyway, a researcher must look at the new tools that are in the world, like ChatGPT. But what has been done? So we have to it is real ChatGPT in our discussion, in our classroom, and so on. Moreover, this is very dangerous. This is not means that we must avoid to the young generation to use ChatGPT. Moreover, what is important is that we need to teach strongly further basic knowledge in the course, as we have to be very dedicated to the educational aims and to fix in the mind of the people that one point is to understand, to have a model, to define problems, and another problem is to use the artificial intelligence tools. Otherwise, without the educational efforts we must be done, the system based on artificial intelligence system in design control system could lead a big collapse. Thank you.